Welcome back. We are looking at dot product, which is chapter 2.9 from your textbook. Yeah. Oops. 2.9 from your textbook. Yeah, chapter 2.9. So, at the end of this chapter, you should be able to determine the angles between two vectors and to determine the projection of vector along a specified line. So, example, if you have a rope here, you have the beam here. So what is the angle in between? You can actually use the dot product to actually find them. So literally everywhere, yeah, angle between these two, yeah, and then angle between this and this, you can find using your dot product. So let's go into dot product. You have actually done dot product in maths lesson, yeah, before my class in your, I think in your calculus 2, or probably simultaneously with calculus 3, ongoing now with this class concurrently. So I'm not going to go into the maths part of the dot product, but I'm going to show how it's going to be used in statics lesson. Yeah, so we have angle, we have force A and force B. So the angle in between here can be determined by the dot product. So it means, look at this, A dot B equals to AB cos theta. Yeah, so A theta will be the smallest angle between the two vectors and is at the range of 0 to 180. It should not exceed 180. Yeah, so dot product characteristic, the result of the dot product is scalar. Yeah, it's either positive or negative number. The units of dot product will be the product of units of A and B vector. Yeah, so you see, the most important is I dot with I will have 1. J dot with J will be 1. Z dot with Z would be 1. Anything that's not the same, you get the answer of 0. So when you dot like AXI dot with BXI, you have a value. But you have AXI dot with BYJ, you do not have a value. It becomes 0. Okay, same like AX with the Z. Okay, you understand it not? So when you open up, you actually have to multiply. So leaving you with AX BX, AY BI, and AZ BZ. So that is the dot product. Yeah. Okay. So with that, you can actually find the angle, because the theta is actually inverse cos of A dot B divided by AB. Yeah. First we look at the theory, then I will go into the calculation. I'll show you an example. Yeah, another thing that you need to actually understand, that this A is the vector. A with a sign of the upside down T will be A perpendicular, and AA will be A parallel. Yeah, parallel. Okay, so what does it say here is that let's go to the textbook, yeah, because the textbook is a bit clearer. So let me just repeat here. Can you see the blue box here? So we have AB equals to AB cos theta. Okay, and then we have AB, another blue box here, AX BX, AY BY, AZ BZ. Okay, we have done that. Now we're going to go to the second part of the textbook, which is this. Okay, observe this. Okay, there are some points that is been highlighted here that you need to understand. So A actually is equivalent to A parallel plus with A perpendicular. Yeah, you can just plus because these are vectors. Yeah, I with I, J with J. Yeah, and then of course if you A perpendicular, it will be A minus AA. Yeah, why I'm telling you this is that because with this you can actually find your missing vectors. Okay, we will look at an example later, then you will understand what I'm trying to say. Okay, so we'll move on to, you can try out 2.14 by yourself. I'm just going to go to a bit more complicated example, which is example 2.15. Okay, so just pay attention. Example 2.15. Okay, now let's look at the frame. The horizontal force is 300 J. So what's given is there is a force of F 300 J. So they want you to determine force parallel and force perpendicular to member AB. So where is AB? AB is this line. So they want perpendicular and parallel forces. So if I were to redraw this, it would be force which is something like this and this. yeah, along this component. So this would be your parallel force, parallel, and this would be perpendicular force, or they have done with the upside down T. Okay, so can you understand? So you need to find this two. Given to you is this 300 J. I'm going to erase all this so that you will have a better view. Yeah, okay, let's go into the working. So you need to find first your unit vector. You remember coordinate A, coordinate B? Yeah, you minus that, you get your unit vector. Okay, that's your unit vector. Okay, so what is force AB? Force AB is your force parallel, right? Force parallel. So what's your force parallel? You can just take force parallel as your 300J, yeah, 300J dot with the unit vector. Okay, so when you do that, you're going to get 257.1. 257.1 is the magnitude. Yeah, it only tells the magnitude of force AB. It doesn't tell the vector. So what do? You need to take the 257.1 and you need to multiply with each the unit vector, giving you this final answer. Okay, so if you are confused, okay, let me just repeat. You find the unit vector first, okay, and then remember from the formula of your dot product. So what is the formula of dot product? FAB is actually F you dot with UB. Yeah, FAB is your F you dot with the unit vector of UB. So where did we get that? Remember the previous just show you the textbook. Okay, you remember this equation that was explained to you earlier on your dot product? Yeah. Okay, remember? Can you see? Yeah, AB dot equals to AB cos theta. Okay, so and then you can also refer to the formula here. Wait 1 second. Yeah, 1 second. Here, can you see this? A, yeah, AA is A cos theta, unit vector of A. Okay, there's another one. Wait, there it goes. Your A parallel is actually your A, yeah, which is your resultant, dot with UA. So that is the similar thing that we are doing in the working here. Can you see that? Yeah, it's just that the naming, yeah, F dot with UB. Okay, so now we have got the value. I'm going to erase this and only highlight the final value, which is FAB is this. Okay, so that's done. Okay, next we need to find the, so what we have here? We have F, which is 300J, and then we have the FAB, which is not right. Okay, let me just write at your angle. We have F, which is 300J, and then we have FAB here, isn't it? We have FAB. So what you need to find is your force perpendicular. So from the formula of force perpendicular, remember the textbook? Yeah, what is force perpendicular? Remember this? Okay, can you see this? A parallel plus perpendicular. So perpendicular will be A minus parallel. So can you see here? Perpendicular resultant force minus with the parallel. So you can take I minus I, J minus J, and K minus K, because this is vector, yeah? So you don't have a J, only J and J. Okay, so this one remain, this minus, and this remain. Okay, so that is your force parallel. So you have actually answered the question. So this is the value. So you have got your FAB and you got your FT. So that is how you solve you use your dot product in statics lesson. Yeah, so with that, please finish up all the homeworks that is being assigned to you, upload them on time. Yeah, and I will see you in the next chapter. We have actually ended chapter 2. Yeah, okay, with that, thank you.